Today we'll be covering everything you need to know about TypeScript, all the fundamentals, and all from one of my students. So he told me he's going to challenge the student and is going to take the whole class and repeat it and do a very brief introduction with all the key points from scratch. So be excited and make sure you subscribe to this channel if this is your first time you are visiting my channel. Then share it and don't forget to turn on the notification. Right, great, let's go.
Good morning, class. Today we are going to be doing TypeScript, intro to TypeScript. So I'm going to try as much as possible to explain all the basic concepts of TypeScript in such a way that you can continue on your own from where we will end in this class. So first I'll do an introduction to TypeScript. So what's TypeScript? TypeScript is a strict superset of JavaScript. Why did I use the word strict? Because TypeScript kind of adds more features to JavaScript, like ES7 features, ES6 features that are not yet supported by all browsers out there. So TypeScript helps us to use those features. Then at the end now, TypeScript compiler will help us to compile our TypeScript code into a JavaScript standard that all browsers can actually use. So it helps us to use advanced features that are not yet supported by all browsers. So we'll go ahead and visit the TypeScript documentation site. You can just go on Google and you type TypeScript. You can type TypeScript on Google, it will take you to the documentation. So that after the course, if you like to know more, you can go to the documentation and you'll be able to understand. This is the TypeScript documentation. What you see as the TypeScript, you can come here, there you go to documentation and you look at the tutorials there, you will help you to understand more. Then as for the features that I said are not yet supported by all browsers out there, to know some of these features, you can go to caniuse.com. There's a site called caniuse.com. So caniuse.com helps you can go to Caniuse. In Caniuse, you can just type something like ES6 here. So if you type ES6, it's going to give you the features of ES6 that are not supported by some of the browsers. Like, look, here we have JavaScript modules, dynamic import. You see that it's not supported by Internet Edge, which is the browser that usually comes with things like Windows 10 and some operating system. You see that even Opera Mini is not yet supporting this feature of JavaScript, this ES6 feature of modules. So you can go to Caniuse and you see some of those features. But now, what TypeScript does is that TypeScript actually helps us to use some of these features, and at the end, TypeScript will compile it into a version of JavaScript that all browsers can actually understand and can run the code without any problem. So you can scroll down to see more of the features that are not yet supported by all browsers out there. ES6 classes, you see that this Internet Explorer is not supporting ES6 classes. That's why it's red here like that. It's not yet supporting it, but TypeScript will help us now to compile our code into a version that Internet Explorer will be able to support. That's why most TypeScript, when TypeScript compiler compiles the code, it kind of targets ES5. So if you search ES5 here, you see that almost all browsers support the features of ES5. Opera Mini supports it, all the other browsers, you see that everything is kind of green. So TypeScript helps us now to use those ES6 and ES7 features, then it will later on compile them to ES5 code that all browsers can understand. So you can check out some of the other stuffs after the course. So I'll kind of go back now to I'll go into my VS Code editor. So to begin with TypeScript, I would like us to do installation, how to install TypeScript on your machine. So to install TypeScript on your machine, you need to install Node. You make sure that you install Node on your machine first, so you can use the npm command. So you can go to Node.js. You see node.js.org here, the first link. You click on it. So when you click on this link, you can kind of download Node, install on your PC, and from there we can use our command line now to install TypeScript. So I'll just consider that everybody has installed Node and we'll move on from there. So you go to your terminal. What you do is you go to your terminal.
Use the terminal normally.
Yes. You go to your terminal. In your terminal, to know if you have installed TypeScript, First, you can type TSC, which is TypeScript compiler -- version. So if you do this, if you do TSC -- version, and you see this command not found, it means that TypeScript is not yet installed on your machine. So if you don't have any version displayed here, it means TypeScript is not yet installed. So we are going to see how to install TypeScript. Once you have installed Node, to install TypeScript now, all you need to do is type npm install -g for global, meaning that once you install it globally on the machine. Okay, so to install TypeScript on our PC, since we are using a Mac PC, we need to install TypeScript on our PC. Since we are using a Mac PC, we need to use the sudo command to tell the Mac that we want to run this command as administrator. So we'll do sudo npm, but on Windows you can just go straight to the npm install. But on Mac you do sudo npm install npm install -g for global. Then now you type TypeScript and you hit enter. Then we'll ask for the password. So you just enter your password. You enter your password and you hit enter. Now it's going to install TypeScript on your PC.
Depending on your internet speed.
Yes, it's also going to depend on your internet speed. So it might take like 5 minutes for some people. And okay, now I have TypeScript installed. So if I go ahead and type tsc -- version, you notice that I have TypeScript version 3.7.4 installed on this PC. So I'll consider that everybody has installed TypeScript on the machine, and we're going to move on to the next concept, which is variable declaration. Now, variable declaration in TypeScript is the same as you do variable declaration in JavaScript. So to do variable declaration in TypeScript is, let me go to my editor. So you just launch your VS Code after installing TypeScript. You head back to VS Code. I'll create a new folder here. I'll just go and create a new folder for this class, so that we'll start everything afresh. We'll start with variable declaration. So I'll go ahead and create a new folder for this. I'll just go and drag and drop my folder into my VS Code. This is my TypeScript folder that I created. So I'll open my folder in VS Code. I'll consider that everybody have done the same. So we'll create our first TypeScript file. Now TypeScript files always end with the extension of .ts, which means .typescript, but it does not change anything. Any valid JavaScript code is a valid TypeScript code. But we cannot say the same for TypeScript and JavaScript, because TypeScript actually have some features that are not yet supported by all browsers out there if you write them in JavaScript. So things like interfaces, we'll see some of them as we go through the course. So I'll do main.ts. Now you see that this is a TypeScript file. If you look here, you see my editor give me something like ts beside the file. Can everybody see the file on the? Okay. So now this is our first TypeScript file. I would like to be using the command interface inside of VS Code to kind of run my commands. I don't want to be going back to my terminal and coming back, so I'm going to use this command line inside my editor. To open this command line, you can just hold your control, then you hit the button below your escape key on your keyboard on Windows. So we're going to write our first TypeScript code, which will be talking about variable declaration. Like I said, variable declaration in TypeScript is the same with variable declaration in normal JavaScript. So I can say let me just say person, or let me just call it say hello. Yes, say hello equal to so if I do something like this is a valid TypeScript code, and as you can tell, it's a valid JavaScript code. We do same thing in JavaScript. So I can just come here and I say console.log say hello. This you do the same in JavaScript. That's why I say variable declaration in TypeScript is the same with variable declaration in JavaScript. So to run this code, what are we going to do to run this code? We use the TypeScript compiler to compile this code into normal JavaScript that all browsers can understand. Because right now browsers cannot support TypeScript, so we have to compile the TypeScript code into JavaScript code that browsers can actually understand. To do that now, I'll just do TSC in my command line. TSC means TypeScript compiler, then I give the name of the file that I want to compile, which is main.ts. Now I'll hit enter, and TypeScript compiler is going to compile my TypeScript code into JavaScript code. So you see that we have one new file here, main.js. When it compiles your code into TypeScript code, it creates another file with the extension of the name of the same file, then with .js, meaning that it has transferred your TypeScript code into JavaScript code and save it in another file. So if I go to this main.js file, you actually see the same code, just that the main.js file is now using var, the var keyword, which means that the let is not yet it's not supported by all browsers. So TypeScript had to compile it to var so that all browsers out there can understand your code. So it's just like compiling those features that are not yet supported by all browsers into features that are supported by all browsers. So you see that we now have a valid JavaScript code. So what can we do to run this code now to see our output? To run the code now, you come back to your terminal and you do node, you run main.js. When you do node main.js, it's going to run this main.js file, and you see we have hello world in my terminal. This hello world is actually running the code. Can everyone see the hello world? Okay. So that's like the first example. The reason why I wanted to really explain this concept of variable declaration is to make you to understand the difference between let and var. The difference between those two, because it's very important to understand the difference. Let is a block scope variable that is scoped to the nearest block, while var is scoped to the nearest function. What do I mean by that? We'll look at one example on this. So let's say let's just say I have a function, even though we'll talk about function declaration later, but let me just take an example of, let's say I have a normal function. This is how we do normal functions in JavaScript. Let me just say hello. Now, inside this function, I have a for loop. Let me use the let keyword first. Let I equal to 0, I lesser than 5, I plus plus. So, doing this for loop now, I can access I inside this for loop. Since I'm using the let keyword, I can actually access my I inside this for loop. But out of this block, I cannot access this I variable. We can access the I between this scope because it is scoped to the nearest block, meaning that it is scoped to this block enclosing the for loop. We cannot access it out. Like if I come below here and I try to say console.log I here, you see we have an error. There's one red line below the I. I hover over it, you are going to see that this one nice feature of TypeScript. It helps us to detect errors at runtime. Does not wait for us to go like when we want to compile our code before we start seeing errors. TypeScript helps us to detect some errors at runtime, not all errors, but most errors you'll be able to detect them at runtime. So if I hover over it, you see that cannot find name I. It's telling us that it cannot find the name I. Why? Because I is only scoped to this block of the for loop. Out of the for loop, you cannot access I, because we are using the let keyword here, which is scoped to the nearest block. But if I use var here, now with var now we don't have that error anymore below the console.log, because var is actually scoped to the nearest function, meaning that anybody inside this function can access the I, because var is scoped to that function block. So that's basically the concept that I wanted to explain about this concept of declaring variables. You need to understand the let and the var keyword. So we'll move to our next concept, which is types. This is one thing that TypeScript is adding to JavaScript. Static typing. Meaning that if you have used other languages like C#, Java, C++, you see that we have the concept of you can declare a variable and say this should be an integer, and that variable must store just integers. If you store a string in that variable, you have an error. You can declare a string, all those type of boolean, it must be true or false. So TypeScript is helping us to add such functionalities to JavaScript so that our applications will not break at some point, because you can declare something like you want a name, like a user to enter something, and you need that thing to be a string, but the user will go and enter something like a number. So TypeScript will help you to like detect that is not supported by the type of like number that you said you needed. So we'll see an example of that. Like I can say in normal JavaScript, I can do this. I can say let name equal to first name equal to Let me just do something like John. Now in normal JavaScript, I can do something like this. I can come here and redeclare first name and give something like a number. I can do something like this. First name equal to 4. And JavaScript will accept. If I compile this TypeScript code, even though we're having this error, you are going to see that we still have a valid JavaScript code that can run very well without any problem. But TypeScript helps to tell you that 4 is not assignable to type string. Why does it say string? Because TypeScript is brilliant enough to identify that when we just pass a string to a variable from the beginning, TypeScript will automatically give that variable a type of string. If I pass a number here, TypeScript will automatically give first name a type of number. But now there's a way for us to actually declare our types from the beginning. Like I can say, I want this first name to be a string. So to do that, I can prefix this concept is known as type annotation. Type annotation is in TypeScript is basically the concept of you assigning types to your variables. That this variable should be a string, this variable should be an integer, a number, boolean, something like that. So TypeScript gives us this feature so that we can include it in our JavaScript program. So if I want to say this name should be I need this name to be a string. In TypeScript, if I do something like this, let first name, and I don't pass anything in the beginning, TypeScript now will not assign any type to this variable. So basically what this means is that I can come here and say first name equal to Donald, and I can keep changing first name. I can say first name equal to true. That's a boolean. TypeScript will accept all of them. Why? Because TypeScript will automatically assign the type of any to this variable when we don't pass any type. TypeScript will assign the type of any. And what does any mean? Any means that this variable can basically store anything. Both types, like booleans, string, number, all of them can be stored in this variable. That's the type of any. So this now, if you know that we have some things in string, like if I come here now and I say, if I say console.log and I do first name here and I do dot, you see I will not have this IntelliSense. There's this thing called IntelliSense, which means we always have this helper, something that will always come up to our editor and tell us that we have these methods that we can actually use with strings. But when we assign the type of any, we cannot actually use that beautiful IntelliSense that our editor always gives us. So to be able to use that, we need to use the concept of type annotation, which means I will come here and I'll prefix this thing I'll use this colon, then I'll kind of add string here, telling TypeScript now that I want this first name to be a string. This is called type annotation. You see now that this one that I assigned true there is having an error now, saying that we cannot assign that type true is not assignable to type string, meaning that this first name was supposed to be a string, but we're assigning a boolean to it, meaning that it will not work. So we'll have to delete it. Now you see that IntelliSense that I was telling you about that we could not use when this variable was of type any. If I come now here and I say first name dot, you see that we'll have this IntelliSense here. We'll have char code, this helper. This thing can actually help you to use some functions. If you forget something, you can check it out. These are basically the type of methods that we can use with string types. So we'll have this, but had it been that I never assigned this string type here, if I come and put this dot now, you see that TypeScript will not give us anything. So type annotation basically helps you to specify the type of a variable. Like if you know the type of the variable at hand, like you know that this needs to be a string, use type annotation. I'll show you the various types that we have in TypeScript, because we basically have 5 types in TypeScript. I'll just go ahead and do some of the basic ones. I can say first name should be of type string. This is the first type, meaning that it must be a string. I can say let age of type number, meaning that it must be a number, something like 1, 2, 3. We have boolean. I can still say let adult equal to adult of type, meaning that I want to know true or false. It's an adult, true, false, of type boolean. Boolean simply means true or false. We all know that. And we have the type of any. Let results of type. Now any, like I explained, any basically means that you can pass anything to it. You can pass a string, integer, boolean, anything to it, and it will basically accept it. Now we can also do an array. So you can specify that you want an array of integers. So with TypeScript you can do let me just say numbers of type number. But now we have to prefix this with these curly braces, this square, this yes, square, you can just call it some square braces. So that to tell TypeScript that we want to create an array of type numbers, meaning that in this array we just have to include numbers. If I come here and I include 1, 2, 3, you see that up to this point we have no errors. But if I include something like a string, like hello, you see that we have an error telling us that type string is not assignable to type number, meaning that this array must contain just numbers. We can also do same for string. You can just change that to string and you do an array of string. And there's also one type of arrays that I need to specify, any. We can do an array of any. Like I can say pupil of type any. Now this array of any now means that we can basically store anything here. We can store 1 here, integer. We can store a string here. We can store boolean here. Anything can go into this array and you accept it. This is a type of any. So with this, I think you have understood the concept of types in TypeScript. So I'll explain inline annotation later on while we're going through the course. When we get to the concept of arrow functions, I'll explain inline annotation, which is another type of doing this string annotation, but in another way. Now we have the concept of type assertion. Now what this simply means is that I can declare first name here, like we have declared first name at the top, and we have assigned it the type of string. Now, if I remove this type of string here, and I want to use that our beautiful IntelliSense that I told you about, like console.log first name dot, let me pass a string here. So if I want to use that beautiful string IntelliSense that I always have, that will give us some helper methods that we can use with string types, and I do my dot here, I will not have them. So there's something called type assertion that can help us to access that beautiful IntelliSense that we always have. So to use type assertion, you open these parentheses. Then in here, you just open this greater than and lesser than symbol. Then you can type string here. Now, what this means is that we're telling TypeScript that, then in here I can use my, let me just type it, then I'll explain. First name. Now, if I come and do the dot here, you see I'll still have this. So what are we doing? We're using type assertion to tell TypeScript that we want to use first name, but we know that first name is a string. So we're telling TypeScript that it should give us that IntelliSense of string, because we already know that first name is of type string. So this is the concept of type assertion in TypeScript. So you basically see people using this a lot in programs. When you check other people's code, you basically see that most people usually use type assertion rather than type annotation. And when you're working with Angular, you also use this a lot. That's if you're working with Angular. So we'll go ahead now with the concept of arrow functions. So arrow functions in TypeScript is basically the same as to do arrow functions in normal JavaScript or ES6. So I'll go ahead and do an example of arrow function. So I can like say the concept of arrow function, I can say let declare that variable of say hello equal to, so to use an arrow function, you basically just need to come here and open your parenthesis, then you use this equal to and greater than sign. This is what makes it, this is what gives the name arrow function. You see that we're using this equal and greater than to declare an arrow function. So if you work with JavaScript, you basically see that an arrow function in TypeScript is basically the same as doing an arrow function in normal JavaScript. So I can like say message, I can pass in message as a parameter, and we can also do an arrow function with no parameter at all. So if you have just one parameter, you can remove these parentheses and you can just do message here. Then if you are like just to return one thing, like let me just say I want to log the message to the console. If I want to just do console.log message, if I want to just do just this single thing with arrow functions, I can remove all of this and make my code even cleaner by just doing this on one line like that, meaning that you just want to do just this one thing. But if you have multiple lines, you have to use the opening and closing parentheses. So I always like to do this because at least it makes your code more readable rather than allowing everything like that. So this is the concept of arrow functions. Let's run this code and see how arrow functions will look like in normal JavaScript. You see that they're basically the same thing. So I'll do TypeScript compiler main.ts. Now to run multiple commands, I can do this symbol, this or symbol.
It's called the pipe.
The pipe, yes, you can use the pipe to run multiple commands. You put one pipe there, then you type the next command. I want to run node main.js after compiling the file, so I'll hit enter and we'll have hello world. That's already compiled the TypeScript code, then run the JavaScript code. So if I go to JavaScript now, you start as this is the arrow function in normal JavaScript. You start as compile it to ES5 standard, which is basically normal functions in JavaScript. These are them. You see that we're using the function keyword here. Meanwhile, in TypeScript, we never use the function keyword. We just use the arrow syntax, but here we're using the function keyword. That's the concept of arrow functions in TypeScript. The reason why it's compiling this code to this format is because not all browsers out there will understand this arrow function syntax. So TypeScript helps us now to compile that ES6 standard code into ES5 standard that all browsers out there can basically use, because all browsers support ES5 code. So we'll go to the concept of interfaces. So what's an interface? An interface is like a way of us to like declare types and use them multiple times. Let me say I'll go ahead and declare a function here. So let me say I have this function that is like to draw points on the screen. Let me say I want to draw like points on the screen. I have a function called draw points. I'll use the arrow function syntax. Let me say let draw points equal to, it takes in the points x and y. Then at the end now we want to console.log x and we want to console.log x and y. So at the end we want to console.log x and y. So what if I wanted x and y to be type of number? I'll have to come here and do the annotation, the type annotation. So I'll have to like do something like number, and I'll have to also come here and say number. So this is called inline annotation. We're actually doing it inside the function as parameters. It's called inline annotation. Like I told you, I'll explain inline annotation later. This is the inline annotation I was talking about. So now, what's the problem with this approach that I just used? If I had to use x and y in multiple places, like let me say I also had another function here like display points. I can say display points that also take this same x and y value. I'll also have to come here and put that type of number. I also have to come here and put the type of number to both of x and y, meaning that anytime that I want to use them, I'll come and use type of number there, which is not good. So this is where interface comes in. I can just create an interface holding x and y, and anywhere we use that interface, x and y must be a number in that position where we use that interface. So to create an interface in TypeScript, we just basically use the keyword interface. Then you give the name of the interface. I can just call it points. Now open this. Now in here I can just say I want x of type number, then I want y of type number. Now anywhere I want to use x and y, I can just come here now. Rather than doing all of this, I can just come here and I can just say, I can still call it point of type points. Now with this approach, I'll have to use x and y as an object. I'll access them as an object. So rather than using x here, I'll have to use point.x, and then for y here, I'll use point.y. So with this now, rather than doing type of number all the time, just imagine that we're having like a function that will take x, y, z, w, like a to z. You see that you have to do type number all the time that you want to use function that will use those things. You do type of number. But with interfaces, you just have to create one interface that holds all of those variables and their various types. Then you can actually use that interface anywhere that you want to use those types. Like now like that, I don't have to do this x and y type of number again. I just have to come here. If I want to call them point again, I can say point of type points. Now in here, if I want to do x, I can only, now x can only be a number. If I try to access these functions and pass the values, let me say I access the draw point function. Then in the parameter now, I have to pass an object having x and y. Now if I try to pass a string for x, if I try to like pass hello for x, you see that you give me an error saying that type string is not assignable to type number. That's because in our interface x is a number, but if I come back to my interface and I change x to be something like string and I come here, you see that this code is going to be valid, just that we need to pass two parameters. That's why you're seeing that red there. So go ahead and pass the second one, y of type number. Let's just pass 4. You see that this code is valid. That's because x is now a string in my interface, and anywhere that I want to use x, it must be a string. But
that one is very clear. That's exactly how you use interfaces. So I think it's more clear for you to understand that interfaces usually are used to declare object or data or those kind of data that have multiple values. Like, for example, an object person with variables that are different from one to another, like numbers, string, boolean, and so on. So when you declare it as an object, and you can declare another variable that is of type, that is of an interface type. Like you are seeing him declaring a pointer of type points, right? And that points is an interface that's having up to 2 variables with their different types. That's great. Go ahead.
Okay, so interfaces, when we say interfaces, it does not only mean that we have to do just like, if we want to do an interface, it must be numbers only and it must be string only. We can do an interface with mixed types. So I'll do like a basic example here. I'll go ahead and delete this code here. I'll do an interface that holds 2 variables, name of type string and addot of type boolean. Addot of type boolean, meaning true or false. Now I can change the name of this interface now into person. So I can come here now and create an arrow function like let check equal to. Now this arrow function is going to take 2 arguments, which are your name and true or false if you are an adult or you are not an adult. So rather than for me to come here and be passing name and adult, I'll just use my interface. So I can just come here and say details. I can just call this detail of type person, meaning that it's going to be expecting an object with something like 2 variables in it or something like that, which one must be your name and the other will be a boolean telling if that person is an adult or not. So I can do something like a check in here. I can use an if statement and say if detail dot adult, meaning that if it's true that you're an adult, I will console.log. You can also use template literals here. You know template literals in JavaScript. I'll console.log the name of that person, detail.name is an adult. Else I'm going to say you are not an adult. So else console.log template literals detail.name is not an adult. So now we're going to use this function. So you see that we're using our interface, but the concept of this interface is to help you, like if I have to use name and adult somewhere else in my program, I'll not have to still specify that the type must be a string or number. I'll just have to use that in my interface that I created. So it's helping you to ease your code, not to be like saying string, boolean all the time. So I'll call my check function here. So it's expecting an object that will have two values actually. So the first one is going to be name, and I'll just pass John Doe. Then the second one is going to be adult, true or false, or say true. So if I call this like this, let's run the code now and see what we actually get. TypeScript compiler main.ts, use the pipe main.js. Oh, I made an error somewhere. Ts main. Yes, I forgot the node. Main.ts pipe run node main. So you see, John Doe is an adult. So now our interface will always make sure that this John Doe here, this name here, when we are calling this function, it must always be a string. If I come here and I try to pass a number for the name, we'll have an error telling us type number is not assignable to type string. So it must always be a string, which is very important when you're working with things like Angular. It will help you a lot. Yeah. So we'll go to our next concept, which is classes. Classes in TypeScript. So I'll just go ahead and delete that code. So we'll deal with classes. So what are classes? Okay, I'll just have to go back to my code, the one for points. Let me reverse this because I want to explain something why we need classes. Because there's this principle known as cohesion in object-oriented programming. So what is cohesion? Cohesion simply means that all things that are related should be like part of one block, part of one unit. You can still say it like that. So meaning that if I have this my function here for draw points, and we know that we're expecting these numbers, and we know that draw points function is going to be working with x and y, then display points will also be working with x and y. So rather than doing these things like that separately, we can just create one class, and inside that class now, anything that has to deal with points, we'll do that inside the class. That way we're respecting the law of cohesion, which says that everything that is related should be a part of one unit. So I'll try to explain that better as I do. So we'll just change this into a class. So I'll do class points. Okay. Hope they understand the concept of cohesion as I'm explaining. Everything that is related needs to be a part of one unit. Like we have these points x and y, we have draw points that is going to be working with x and y, we have display points that is still going to be working with that same x and y. So rather than separating all of these things, we can just create one class that deals with points, and everything that has to do with points, all the functions that have to do anything with those points, we'll use them inside of that class, meaning that we're grouping everything. So if we want to like export it and use it in another file, we'll just export that class and we can access it somewhere else with everything that has to do with points. So that's where classes come in. So we can create a class called points. Now inside this class, we can just say x of type number and y of type number. So inside this class now, we can create our function of, let's say, and when declaring these functions inside a class, you don't actually use that function keyword, or let me see. Okay. What? Nothing, sir. So let's say inside this class we have x and y. So we have this thing called constructors. So I'll create a constructor here. And here now I can still change the name of x and y. I must not call them the same x and y. So I can just come here and I can call this num1 of type number and num2 of type number. Then I can now say this dot x equal to num1 and this dot y equal to num2. I'll explain everything when we want to use the class so you understand better what the constructor is doing and all those. But for now, I'll just do these things so that you see them. I can now come here and say get distance. Now, this is my get distance function. Inside here, let me say I want to console.log x and y. I'll say console.log. To access x and y, we can actually do, we use the this keyword, meaning that we are referring to the class, to the parent scope, which is the class. We are pointing to the class. This dot, you see that we can get this dot x and this dot y, all of those. I can console log this dot x and then this dot. So where is
that distance? It's just display. That display or distance.
Distance.
Yeah, the name should reflect what you are doing.
Okay. I can say, okay,
Display point for example.
I can call this display point.
Okay.
So with this display point now, I want to display the points x and y. So what if we never had anything like the constructor here? This code will still work, but the thing now is that if I come here and I say, now to use a class, you need to create an instance of that class. So how do we create an instance of that class? I'll have to come here and I'll say let point 1 equal to, use the new keyword, new points, and I'll give the name of the class. Now this is an instance of that class that we created, meaning that with point 1 we can access everything inside that class. If I do point 1 dot, you see that we actually have the x, the y, and the display point. So now I can say point 1 dot x equal to 12 and point 1 dot y equal to 13. Then I can call point 1 now dot display point. I can call my display point function now. Then if I run my code now, you see that I've not saved that file.
No, you have to run it back.
Yes.
You run it back again, you won't know. It seems like you catch the old content that was inside the JavaScript.
Yeah, that's what happened. So I'll do TypeScript compiler. Let me just do it manually. Type main.ts. Should actually compile the TypeScript code, then node main.js. You see that we have 12 and 13. But what if you had like x, y, z? Like we have so many things in here like x, y, z of type number. We have so many of them. J of type number. So we have to actually come here and be doing point.x, point.1.x, point1.y point. So that's where constructors come in now. With constructors, we don't have to come and be doing point 1 dot this, point 1 dot this. We can just actually create, I'll go ahead and remove this z and j that are added here. We can actually just come here and create our constructor. We can create our constructor here. We can still call them the same x and y. X of type number and y of type number. Then inside our constructor now, I'll say this dot x equal to x, this dot y equal to y. Now you see that we have an error down here where we are creating a new instance of that function. That's because when we use constructors, when we create an instance of that class, we need to pass in the required parameters, which are the x and y that we pass inside the constructor there. So you see here that it's requiring two arguments. This error is telling us that expected 2 arguments but got 0. So I'll have to pass my x here, and I also have to pass my y here. So I can just pass now 12 and 15 here for the 2 parameters. It's going to accept them because they are of type number. If I try to pass a string here, it's not going to work, because in here I've specified that x should be of type number and y should be of type number. So if I try to pass a string here, it's going to tell me that argument of type string is not assignable to parameter of type number. So I'm going to cancel the string and I'll pass 15 here, which is a number. So if I run my code now, you see that if I run my code, you see that we have 12 and 15, which are the arguments that we actually passed inside of the where we were creating a new instance of this class. So that's the concept of constructors. It actually helps you to just do everything. So you basically see that classes actually help us. Like if we had something like drop points here, or let me just say, how can we call this one? Okay, let's just say drop points. That also needs x and y. you see that our draw points now, we don't have to separate everything. Draw point, display point, they're all working with x and y, so they're both found inside this one class that is called points. Meaning that everything concerning the point is found inside this class. Meaning that we are now respecting the principle of cohesion, which states that all related things should be found in one unit. So we are going to look at access modifiers. Now, what are access modifiers? They are things like private, public, and protected. If you have used other languages like Java, you know about access modifiers. We have private, public, protected, and so many others. So to use access modifiers, so how can they help us? Now you see that, let me say I have this variable here called something like, let's see the concept of access modifiers. Okay, let's say we have a class here known as pupil. Now this class needs a person's name of type string, or let me call it person. Yes, person will be good rather than using people when we are talking about one person. Now person will receive a name of type string. So, and the person's age of type number. We'll create our constructor, and in here we can like say name of type string and age of type number. So you don't need to name them the same. You don't need to name the name and the age inside the constructor the same. I can still come and call this name 1 and age 1 or something else. What matters is that you need to reference the person, the name in the class, the one out of the constructor, and assign it the one inside the constructor. Like I can say this dot name equal to name. Now I'm assigning the one that we're going to receive as an argument to the one that is found inside our class. So I can come here and say this dot age equal to age. So what if we want that when the user click on a button, it should actually let me say increase the person's age. Or let me say we need to check if the age is greater than or lesser than 18 years to display if that person is an adult or that person is not an adult. What are we going to do? We'll simply create a function here called check age. Now the check age function is going to have an if statement that says if this dot age is greater than 18, then once we display to the console that this dot name is an adult. Else, we can use the else, or we can use else if to actually check if the age. But if the age is not greater than 18, means that the age is actually lesser than 18. So we'll just do else console.log console.log this dot name is not an adult. So access modifiers, how can they help us in such situations? Like I said, we have private, protected, and public. How can they help us? Let me say we only want the person's age. We want to check if that person's age is greater than 18, then we display that that person is an adult. Now, normally, if we come out here and we create an instance of this class, like let person 1 equal to new person, we actually have to pass that person's name and age. So we'll pass the name of John Doe, then we'll pass the age of 1,000 years. Now John Doe is 1,000 years, so normally the console has to display to us that John Doe is an adult. But if I come here before calling that function that is going to check age, because I'll actually have to call person1 dot check age, this method that is going to check if that person is an adult or not, and tell us that. Let's run the code and you see that it will actually tell us that John Doe is an adult. TypeScript compiler main.ts, then we run node main.js. You see that John Doe is an adult. But I can come here and now I can say person 1 dot age. I can change Dondo age to 12. Let me just say 12 years. And you allow me to change the age. If I run this code now, you tell us that John Doe is not an adult. Meanwhile, John Doe is of age 1000 years, but if I run TypeScript compiler main.ts, if I run the code again, it will tell us that John Doe is not an adult. Node main.js. John Doe is not an adult. Meaning that we're able to change John Doe's age out of the class, which is not good. This is where access modifiers now come in. So once we make it in such a way that we cannot access the age of John Doe out of this class. So to do this, we use the private access modifier. By default, all the variables are of type public. So to make sure that we are not able to access John Doe's age and change it out of the class, and we can only change John Doe's age inside this class, we have to use the private access modifier. So you come here where we are declaring the name and the age, you just prefix it with private name, and you come here and you say private age. Just by doing this, by adding this private access modifier, you see that we have an error here for the age. You see that property age is private and only accessible within the class. Meaning that we cannot I hope that everybody understand the concept of these access modifiers, because it's very, very important. Private actually means that we cannot access, we're like making this property to be like, we cannot access the age out of the class. We cannot access this age out of this class, only within the class. While public, we can access it both inside and outside. Then protected is having some kind of concept, just like private, but the difference is that if you like have a subclass that extends this person class, we can access the protected inside that subclass. So, but with private, even if you have a subclass, you cannot access the private variable inside that subclass. So now like that, we cannot access John Doe's age out of this class, so you cannot change the age. It's giving us an error. So we'll save that. What if we wanted to console or log? Or let me say, yes, let's say wanted to be like, now if you see our code, you see that we have like, here we have name, string, age, number, and here we also have private name. With access modifiers, we can remove this one here, these two declarations here. We can remove them and just come here where we have our constructor, and then we can remove this dot name, because now we don't have any name in the class scope. So we can just come here now and prefix this with private name and private age. So our code is much cleaner. So what if we wanted to be able to like kind of access the age out of the variable, and let me say we want to like console.log person1.age. Once you console.log the age out of the variable, you see now that when we do the dot, we only have check age. That's because check age is public. Then name and age are private. Let me make name to be public so that you actually see the difference. If I make name to be public, you now see that if I come and do person1 dot, you see that I have check age and name. These are the two public variables. The private one, which is the age, we cannot access it out of the class. What if we wanted to be able to like access the name and the age out of the class and display them, but we cannot modify them? Meaning that we want to just display them. We can access them just to display and we cannot modify them. With normal JavaScript, we can do something like this. I'm going to explain the concept of setters and getters that we can use to do this, but let me first try to like explain it in normal JavaScript way, like the way that we can actually access the age out of this variable. We can create a function here like get age. Now what this will do for us is that it's going to return us, because we know that we can access the person's age inside of this class. So we'll create this function that will return this dot age, meaning that it's going to return us the age. It's not giving us any right to modify it, but it's going to just return us the person's age, so we can have access to that person's age. Now to be able to get access to that person's age, now to console.log the person's age here, I can actually say person1 dot get age. Now the get age will help me to get that person's age, because it's going to return the person's age to me out of that class. So if I clear my console now and run this code, you see that we can actually access that person's age, but we cannot modify it because that function just returns us the person's age. These are important things to understand because they will actually help in Angular. So I can run node main dot. You see that we have John Doe's age here 1000, meaning that we're able to access the person's age even though it's of type private, but we use a method because a function inside a class is called a method that actually returns us the person's age, but it does not give us any right to modify it. What if we wanted to be able to like modify John Doe age? We can also create another function like modify age that takes in a value. No, so I'll explain setters and getters, but I want to show like if you want to do it with normal JavaScript without using setters and getters. I can create another function called modify age that takes in a value. Then I'll set this dot age equal to value. This way now, this method now is going to take a new age, then go now inside the class and set the old age to this new age because you can actually access the age inside the class. So I can come now here, like if I want to change the person's age now, I can say person1 dot modify age, then I pass in my new age of, let me just say 10 years old. So if I run this now, it's going to tell us that John Doe is not an adult. TypeScript compiler main dot. If I run this code now, you see that John Doe is not an adult because we're able to modify his age even though it's of type private. And the reason for this is because sometimes you need to make some variables private and just grant read-only right to the people out of that class. So we'll see the concept of getters and setters on how to use them to do this in a much cleaner way. So you see now that John Doe is not an adult because we're able to change John Doe's age here to 10 using this our method that is going to take a new value, then go inside our class now and modify the age. So, but with this approach now, we're accessing the age here as a method. We're calling it a function. We're not actually accessing it like a property. What do I mean by that? If I come here and our name is of type public. So if I want to access the name here, if I do person1 dot, you see that the name and the others they're different. It's having one blue something beside it like that. This identifies that this is a property, not a method. Why methods? You see that they actually have these purple boxes. What if we wanted to access the names as a method, not as a property, not as a method, and we wanted to make them private and still have that right to access them out of this class without modifying them? We use the concept of setters and getters. Now, a setter, what a setter does is that it helps us to modify the value of something, a private field inside our class out of the class. While a getter helps us to have access to private values that are inside our class out of the class. How do we use them? I can come here now, rather than doing get age here, I can come here and I say, let me say I want to grant read-only access, like you can only get John Doe's age out of the class, but you cannot modify it. I can use a getter for that. I'll use get, and I can call it. Now, if you want to have the same name like age, what people always do is that you come and prefix this one up here with an underscore. That underscore symbol, you have to come here and the shortcut command is not working. No, I wanted to. There's one command that will modify it everywhere, so I'll have to manually go now and. So you can prefix it with an underscore like this. Then, by so doing, you'll be able to. I'll just call this person2, not person1 anymore. So I can come here and I say get age. When I use get age here, I'll just have something like this that returns the age. This dot underscore age. Now what's the difference with this? You might look at this as if it's the same as the other approach that we took, but it's different. Now if I want to access this age out of this class, if I do person1 dot, you see that this age is actually displayed as a property. That if you want to assign the value, we'll actually do equal to and we'll assign it. We'll not have to call by that function call like this. But now if we try to assign something here, you see that it cannot go. Why? If we hover over it, you see that cannot assign to age because it is a read-only property. That's because getters only give us read-only, meaning that we can actually read the person's age out of the class, but we cannot modify it out of that class. Meaning that if I want to console.log the person's age here, I can do that. I can console.log person2.age and it's going to work. But I cannot modify the person's age out of this class. This is read-only property. So how can we do to modify the person's age out of this class even though it's of type private? We use a setter. There's another concept called setter, meaning that we'll come here now and we'll say set age. We'll still call it age. Now this one is going to receive a value. And I'll explain the difference between this and the previous approach because you might look at them as if they are the same but they are different. This is not a method, this is a property. So here now I'll access this dot underscore age and set it equal to this new value that we'll receive from the outside, out of the class. So to use this setter now, if I come here and I say person2 dot, you see now that if I do age now and I assign something to it like 12, it's working very well there. We don't have any errors because we're now using a setter. Now this value that you see here in this setter inside our class, this is the value that we'll pass here using the equal to sign as if we're assigning a normal value to a variable. Meanwhile, with the other approach, we have to do a function, we have to like call a method and pass an argument to that method. But now with this approach, we can actually access them as normal properties without making any function call. So if I do this, it's going to help me to modify that inside our class. And this concept of getters and setters is very, very important when you want to start using things like Angular. It's very, very important to understand getters and setters. It will help you a lot with component interaction. So we'll go now, like let me run this code so that we'll actually see that we can actually modify the person's age out of the class. I've changed John Doe's age to 12. So if I run my code now, TypeScript compiler main dot, let's see that out. Now you see that we have an error. We have an error in the console telling us that accessors are only available when targeting ECMAScript 5 and higher. TypeScript will always tell us this, so we have to tell TypeScript that we want to target ES5. So how do we do this now in our console? Since these accessors they are not like accessible unless we are targeting ECMAScript 5 or higher. So to do this now, we'll have to run TypeScript compiler main.ts -- target, telling TypeScript now that we want to target ES5. You do this -- target, then you put ES5 there, and you run the code now. You see now that we don't have any errors, meaning that we already told TypeScript that we want to target ES5. So it targeted ES5, and now we don't have any errors anymore. So I'll run node main.js. You see that we have 12, meaning that it actually changed John Doe's age using our setup.
So we can even target ES6.
Yes.
Okay, that's great.
So now you can see that our getters and setters that are working properly. We're able to set the value of the person's age out of the class, even though it's a private property. It's of type private. But we're able to access it out of the class and set it using getters and setters, which is very, very important to understand. So now there's one type that I forgot to explain to you earlier on, which is of the type enum. There's a type in TypeScript called enum. Now we have string enum and we have integer enum and we have this other enum. The name is something like interpolation enum that have both string and integer, all of the others. So I would just like to explain this concept of enum since it might be important for you to just know about it. Enum, type of enum in TypeScript. Now I can come here and I say enum. Let me just call it numbers. Now in here, inside this object now, I can say num1, num2, and num3. Now by default, this type of enum is going to assign 1, 2, 3 to these people for their value. If I console.log num1 here, we also see how to declare string enums. If I console.log numbers dot num1 here, why are we having this? Okay, I never spelled the numbers correctly. Numbers dot num1 here, and I run this code, you see that the value is the value for num1 is going to be 1, because enum like numbers them in order, but you can number them by yourself. But if you just do them like this by default and you run node main.js, you see that we have 0, it begins from 0. But I can come here, let me say I want my numbers to begin like from 10, I can assign 10 here. But now if I come here now and I run num2, num2 is going to be 11, because enum just increment now, everybody behind this like +1, +1, +1. If I console.log num2 and I run this code, if I run this code again, you see that num2 is 11, and I can assign to all of them. I can assign a different value here like 14, and I can come down here and I can assign 88. I must not follow them in order. When I'm assigning them by myself, I can assign any value to any of them. So we have string enums. This is like number type enum. This is for numbers. We have string enum, meaning that we can also assign a string to. And the important thing about enum is that it creates constants that cannot be changed. You cannot change anything of this enum out of the enum. You cannot do numbers dot num1 and you assign a new value to it out of this thing. It will never work. It's a read-only property. You cannot change anything inside. It means that if you want to declare some variables, like let me say pi, the value of pi in your program, and you want that it should always be 3.14, you use something like an enum. If you declare pi inside this enum, anywhere in your program, pi must be 3.14. Nobody can change that value of pi out of this enum like that. It will always remain that same constant. So that's the concept of, that's the importance of enum, why people always use it for some cases, like when you want to declare a variable that you will not change the value anytime in the future. So we have string enums, meaning that we can also come here and we'll create an enum of names. We can create an enum of names. Now this enum of names can contain something like name1 equal to John Doe. Then I can also pass name2. You can pass as many names as you like, but I'll just pass 2 names for now. This is an enum of strings, and you cannot change any of these strings out of this enum. They must always remain. Name1 must always be John Doe, and name2 must always be Fred. You cannot access them out of this. You can console.log names.name1 now, and let me run this one, then we'll see how enums are declared in JavaScript. When we compile the code, let's compile this to JavaScript code. You see that the code is complex. You cannot even, if you are not an expert in JavaScript, you will not understand what that code is even doing. Meanwhile, it's very, very easy to declare enums in TypeScript. So let's run node main dot. You see that name1 is John Doe, and we cannot change that out of that. So let's go to our JavaScript code. Look at enum in JavaScript. This enum in JavaScript, when the TypeScript compiler compiles the enum to JavaScript code, this is what you get. So you see that the code is complex. They are just mixing up some stuff there, but at the end you will still get the same results as this. So I would like us now to go into modules. Modules are another important feature, meaning that we can actually, let me say, I'll go back to this our class. Let me say we wanted to have this class that contains these persons in its own file, in a separate file, so that will make our code much cleaner. And anytime that we want to just use a person, we can come into this file and import the person class and then create an instance of that person class anywhere that we want to use a person. This is where modules come in. They help us to write cleaner codes. So how can we use a module to make this our code much cleaner? I can come now here and I create another TypeScript file called person.ts. Now inside of person.ts, I can just copy this our class of person. I can copy the whole person class. I'll cut it so we don't have the person class here anymore. Then I'll paste it here. Now let me say we want to use this person, want to like check a person's age inside our main.ts. Let's say we're working with this main.ts and we're creating something, and we want to be able to like check a person's age inside of main.ts before doing something. Meanwhile, we have the code that is doing that in another file, which is person.ts, and we want to be able to access that code inside main.ts and check that person's age before, and have that code now to check the person's age and then return us with a certain result. How do we access it? You see that here we cannot access these things anymore because new person. If I come here now and I say let person 3 equal to new person, we have an error here. Okay. It's actually telling me that I expected 2 parameters, but let me just say this is our blank file here. Once we're able to work with this person class inside of main.ts, we use the concept of modules, which means we can actually export this class. You can just add something like export class person. When we use this export now, what happens is that TypeScript is going to recognize this file as a module. So in Angular, we actually have modules also. You see the concept of modules in Angular, where there are some things that if you want to use, you import them from Ajahu Angular/core. That's the module that those files are found in. So this, like, we are creating our own custom module here called person.ts. Once we use this export now, this file is now a module. So if we want to use the person inside our main.ts, we'll have to import it. So to do that, we'll simply do import here, and we'll open this parenthesis. Now here we'll type import person, meaning that once we import person, now we'll have to tell TypeScript where to go and import this person. So we'll say person from, we open this dot slash. Now the meaning of this dot slash means that in the same directory. They are all in the same. If somebody was inside a folder, we'll have to navigate to that folder. But when we use dot slash, means that we want to access something in the same direction. Then we'll enter person, we'll now type person there. We'll not add the .ts there. It's not necessary. We'll not add the .ts there because TypeScript already knows that this is a TypeScript file. It's going to do that for us. The compiler will do that for us. So we don't need to add .ts there. We just need to specify the file where that person import is going to be coming from. So with that now, we have imported this our person class into our main.ts. How do we use it now? We can say let person1 equal to new person. Then we can actually pass the name now and the age. We can actually pass the name and the age. And now inside this, we can be able to access all the same things that we were able to access when this person class was inside this same file. It will work the same way because we already imported the person here. If we have multiple files that have to use this same person class, we'll just go there and import. We'll not have to go and redeclare that class. We'll not have to go and create this class everywhere that we want to use this logic. We'll go and create the class. We'll go and create the class. No, we just have to. You don't have to do that. You just have to create a module like this and export that class. Then anywhere now that we want to use this logic, like to check the age, we just have to import that person class, and then we can access everything. Now I can say person1 dot, I can call the check age now like that inside this main.ts file, and we don't have any error. If I run this code, it's going to check John Doe's age and return us with the result for the age. So I can now say TypeScript compiler main.ts, or I can just do asterisk. This asterisk sign means that we want to compile all the .ts files, including the person.ts and the main.ts. So it's going to compile all .ts files. You see, we have this error for that because we never targeted ES5. It's for the, because we use the getters and the setters. So I'll clear my console and I'll target ES5. I'll say TypeScript compiler. Use the asterisk to compile all the TS files .ts dash target ES5. Now our code is going to run very well. Then we can now run node main dot. You see, John Doe is an adult. Now it was able to go into the other file, do the logic, then just return us the result inside our main.ts, and we can use it. Like I can still store this result into another variable. Let me say this result I was like supposed to store something like access, meaning that I want to store access here, or like message to tell us if John Doe is an adult or not. I can still use it, I can store it like that, then I can console the log message here. It will still go. Meaning that we can now do our logic in this file, then use that logic in this other file. So that's the concept of modules. You can actually export your code and import the code in another file and use the code. And this is a very, very important concept, because in Angular, you actually see people importing things at the top of file saying import this from Angular / this, import this, import this. Those are modules. They're actually importing some code that somebody wrote so that they can be able to have access to that code and use the code in their own files. So I hope everybody is understanding the concept of modules. It's going now. Mr. Rene.
It's difficult.
Okay.
It's very, very important, because in Angular you are going to use that everywhere. You will always be seeing in Angular import from, or any class you will be seeing export, right? So that's module. To just make your code more modular in such a way that the things are more, concepts are separate. So like we used to say, separation of concept. Every piece of code that is solving a particular problem should be on its own file, and then you can import it everywhere you need that functionality and just use it. Very, very important to notice. Thank you.
Which improves your reusability.
Yeah, that's code reusability.
You can reuse this same logic as many times as you like by just importing the class that you exported in this other file. So you don't have to write this all the time. So with this, I think we have explained some of the important features of TypeScript that you will need them a lot when working with things like Angular. So to find out more, you can go to the TypeScript documentation and read some stuff there. And I would like to go back and tell you some key features to take note of, like the access, these properties, get and set. Try to understand them very well. If you have any question on this get and set, you can ask so that you can clarify, because this is something that is very, very important, and it took me some time to understand how it really works. So if you have any question on it, if you don't understand how this get and set works, you can ask your question then. Okay, it means that everybody really understood how everything is working. So with that, that's all that I prepared for the TypeScript class. So with that, I think we are done.
That was wonderful.